the continuation of the binomial distribution definition. Now we are finding the constants of binomial distribution. Constants of binomial distribution. The constants of binomial distribution means in that three are there. One is the mean of binomial distribution, variance of the binomial distribution, and mode of the binomial distribution. In this, constants are, first one is the mean of the binomial distribution, second one is variance of the binomial distribution, third one is mode of the binomial distribution. First we are going to discuss about the mean of the binomial distribution. It is very important, mean of the binomial distribution. The mean of the binomial distribution is given by P of x is equal to small r, that is equal to P of r equal to NCR P power r q power n minus r, where r is equal to 0, 1, 2, 3, so on n, and the relation with the q and p is q equal to 1 minus p. Here mean of x random variable is denoted by the mu equal to expectation of x, that is equal to summation r equal to 0 to n r p of r, that is equal to r is 0 into p of 0 plus 1 into p of 1. Before of this, p of r is nothing but that is sigma r equal to 0 to n r into NCR p power r q power n minus r. Here we are writing this it as r is the 0 into NC 0 p power 0 q power n minus 0 plus 1 into NC1 p power 1 q power n minus 1 plus 2 into NC2 p square q power n minus 2 plus so on plus n into NCn p power n q power 0. Here first of all we are finding the NC0, NC1, NC2 values. Here NC0 equal to n factorial by n minus r factorial into r factorial, that is 1. NC1 equal to n factorial by n minus 1 factorial into 1 factorial, that is n minus 1 factorial and factorial get cancelled, that is n. NC2 equal to n factorial by n minus 2 factorial into 2 factorial. This factorial is n minus 1, n minus 2 factorial, factorial, n minus 2 get cancelled, n into n minus 1 by 2. These are the values. So NCn is also n factorial by n minus n factorial into n factorial, that will be 1. So here we can substitute NC0 is 1, 0 into something is its 0 plus NC1 is 1 into n into p q power n minus 1 plus NC2 is n into n minus 1 by 2 p square q power n minus 2 plus so on plus NCn is equal to 1 n into 1 p power n q power 0 is 1. So here we are taking in all terms NP. NP is common, then q power n minus 1 plus n minus 1 by 2 into p q power n minus 2 plus so on plus np common p power n minus 1. So it can be written as this is nothing but p plus q whole power n minus 1 using the binomial theorem. Using the binomial theorem, we can expand the p plus q whole power n minus 1. We are getting the same combination of the sum of the terms only. Here p plus q, we know that since p plus q is equal to 1, so np into 1 power n minus 1, this is equal to np. Therefore mean is equal to mu equal to expectation of the random variable x equal to np only. This is the constant value, that is mean is equal to np. Next constant is variance. Variance of the binomial distribution. Variance of the binomial distribution means, by the definition of the variance, v of x is equal to expectation of x square minus expectation of x whole square. That is, v of x is equal to summation r equal to 0 to n r square p of r minus np whole square. It is equal to summation r equal to 0 to n r square into nc r p power r q power n minus r minus n square p square. Again we can substitute the r values. It's 0 square into nc naught p power naught q power n minus 0 plus 1 square nc1 p power 1 q power n minus 1 plus 2 square nc2 p square q power n minus 2 plus so on plus n square ncn p power n q power n minus n, it's 0 minus n square p square. It is equal to nc naught is 1, 0 into something is it's 0 plus nc1 is n p q power n minus 1, 1 square is 1 plus 2 to the 4, nc2 is n into n minus 1 by 2 p square q power n minus 2 plus so on plus n square ncn is 1 p power n q power naught is 1 minus n square p square. Here from the all we can take in common this np is here from all the terms np is common to 2. Here np into q power n minus 1 plus 2 into n is taking outside n minus 1 2 into n minus 1 p q power n minus 2 plus so on plus n p power n minus 1 minus np. Okay, this is n square p square is np. Okay, here we are getting now relation, so we are taking here adding and subtracting with r, then we get the relation, that is the by using of the binomial theorem we get relation. So Here this is the relation is there. From this we are writing r equal to 0 to n r square NCR p power r q power n minus r minus r NCR p power r q power n minus r plus r NCR p power r q power n minus r minus, it is mu square only we are writing, n square p square is nothing but mu square. It is equal to sigma r equal to 0 to n r square minus r into NCR p power r q power n minus r plus this summation is from for all. This is nothing but r into NCR p power r q power n minus r mu minus mu square. So here from this we are writing r is common, that is r equal to 0 to n r into r minus 1 NCR p power r q power n minus r plus mu minus mu square. Why we are taking like this means we get the binomial relation of this term. So first we can substitute r equal to 0, 0 into 0 minus 1 NC naught p power naught q power n plus 1 is we are taking 1 into 1 minus 1, it's 0 NC1 p power 1 q power n minus 1 plus 2 we are taking 2 into 2 minus 1 NC2 p power 2 q power n minus 2 plus n3, 3 into 3 minus 1 NC3 p power 3 q power n minus 3 plus so on, and we are taking n into n minus 1 into NCn p power n q power n minus n is 0 plus mu minus mu square. From this in the previous we are getting 2, so there is no relation, that's why we are adding minus r NCR p power r q power n minus r plus r. So these two are zeros, 1 minus 1 it is 0, 0 into something it is 0. So we are getting 2 into 2 minus 1 is 2. NC2 is n into n minus 1 by 2 factorial p square q power n minus 2 plus 3 into 2 NC3 means n into n minus 1 into n minus 2 by n minus 3 factorial, n minus of 3 factorial get cancelled into by 3 factorial p cube q power n minus 3 plus so on n square minus n into p power n plus mu minus mu square. Here 2 factorial get cancelled. 3 factorial means 6. Here 3 2s are 6. Get cancelled. Here taking common of n into n minus 1 into p square is common. The remaining terms are q power n minus 2 plus n minus 2 into p q power n minus 3 plus so on plus p power n minus 2. Why? Because this is nothing but n into n minus 1, p square means p power n minus 2 plus mu minus mu square. Here this is the binomial representation, it is n square minus n into p square. From the binomial theorem it can be written as q plus p whole power n minus 2 plus np minus n square p square, since binomial theorem, using the binomial theorem. And p plus q is equal to 1, from this 1 power n minus 2 is also 1. It is equal to n square p square minus np square plus np minus n square p square. N square p square, n square p square get cancelled. np is taking common 1 minus p, it is equal to npq, since q equal to 1 minus p. Therefore, variance v of x equal to npq. This is the constant of the binomial theorem, another one, or binomial distribution knot theorem. The next one is mode. Third one is the mode of the binomial distribution. Mode of the binomial distribution means we know that P of R, that is the probability binomial distribution, is P of R equal to NCR P power R Q power n minus R. So here we are taking the next probability, that is NCR plus 1 P power R plus 1 Q power n minus R minus 1. This is the first equation, it is the second equation. Why? Because we are finding the mode, means the equation 2 is divides with the equation 1. From this, P of R plus 1 by P of R, it is equal to NCR plus 1 P power R plus 1 Q power n minus R minus 1 by NCR P power R Q power n minus R. This is equal to n minus R by R plus 1 into P by Q, by, because here we can take n factorial by n minus R minus 1 factorial into R plus 1 factorial P power R into P Q power n minus R into Q power minus 1 by whole by n factorial by n minus R factorial into R factorial. R factorial get cancelled. It is previous n minus R minus 1 factorial, this factorial. N factorial get cancelled. So this denominator comes in the numerator, and numerator denominator is denominator. Here P power R Q power n minus R Q power n minus R Q power n minus R cancel. P power R cancel. We are getting n minus R by R plus 1 into P by Q. Therefore, P of R plus 1 is equal to n minus R by R plus 1 into P by Q into P of R. This is the mode of the binomial distribution.